Alright, so welcome back to the channel. This is Pendulmatics. I am Pendulum, your tutor, and it's a pleasure to have you back here. Today is a good day because we are moving into another topic, a very popular topic when it comes to mathematics. Actually, this is 3 topics in one. We'll be considering indices, logarithms, and sorts. Alright, so we'll take them one after the other. We'll start with indices, deal with it for some days or for some weeks, and then we'll look at logarithms, which is kind of like the bigger part of this topic, and then we'll look at sorts. Alright, so you're welcome. If you're new to the channel, do well to subscribe. All we do here is teach and talk mathematics. Alright, subscribe to the channel, ring down notifications bell so that whenever we drop new videos, you'll be notified to come and watch and to learn. Alright, so we are starting with the laws of indices. We're starting from the basics. So as we go on, please, I enjoin you to like the video if you find it helpful and relevant. Then drop your thoughts in the comment as well. Do not forget, I want to read what you have to think about the video. And finally, share the video to your friends, your classmates, your colleagues, whoever you know will need it. Share it on your WhatsApp status, share it on Facebook and everywhere. Alright, so welcome. Let's begin. Now we'll start with the definition. Remember, we're looking at indices. So let's look at what is an index. Index is the singular form and indices is the plural. So an index, which we can also call an exponent of a number, is the power to which that number is raised. Alright, the index of a number is the power to which that number is raised. For instance, here we have a raised to power 3. Alright, so this 3 is the index of this number. That's the power to which this number is raised. And what do we mean by raised? Multiplied consecutively. That is repeated multiplication. In the indices or exponentation just talks about repeated multiplication. So if I say a raised to the power of 3, what I actually mean is a multiplying itself 3 times. So a times a times a. That's just what it means. If I say 2 to the power of 3, I mean 2 times 2 times 2, 3 times. Alright, so exponentation or indices is just repeated multiplication, consecutive multiplication. So in something like this, 3 is the index or the exponent and a is called the base. Alright, so if I have 3 raised to power 4, for instance, 3 is my base and 4 is my power, my index or my exponent. Alright, so that's just the definition of what indices is. And then when we are working with indices, we have some laws that guide us, and there are about 6 of them here that I'll be introducing. So I've already written them down to save time. I'll just explain them and then do the examples attached to each one. So note that the laws are effective when x, a, and y are not 0. If they are 0, then some of these laws will be nullified. First of all, we have the multiplication law. Multiplication law of indices, and it simply states that when you have 2 indices multiplying each other and their bases are similar, like what you have here, you have a raised to power x multiplying a raised to power y. As long as their bases are similar, you can pick one base and add the powers. That's the multiplication law in essence. So when you have 2 bases multiplying each other, 2 indices multiplying each other and their bases are the same, it's equivalent to picking one base and then adding their powers. Pick one base and add their powers. Alright. For instance, in this case now we have 2 raised to power 3 times 2 raised to power 2. Now we can see that they both have a base of 2. They have the same base, so I can just pick one of the bases 2 and then I add the powers 3 plus 2, or I add the indexes, and this will give me 3 plus 2 is 5. Alright, and 2 raised to power 5, that means 2 times 2 times 2, 5 times. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and then 16 times 2 is 32. So 2 raised to power 5 is 32. Alright, so that's the answer to this. Alright, if you want to check it, you can still do 2 raised to power 3 is 2 times 2 times 2, which is 8, times 2 raised to power 2 is 2 times 2, which is 4. 8 times 4 is 32, if you want to confirm it. Okay, so you can still do, this is 8 times 4, which is to give you 32. So just remember, for this case, in a case like this, for instance, this is 5 raised to power x plus 1 multiplying 5 raised to power 2x minus 3. Now, what you look at, are the bases the same? Yes. Pick one of the powers. 5, pick one of the bases, and then you just add their powers. So you have x plus 1 plus 2x minus 3. Just add their powers, and if we add this, the base is still here. X plus 2x will give you 3x, plus 1 minus 3 will give you minus 2. Alright, so this is, I've resolved this into this. Alright, so take note of that. Now, in some cases, you may need to change the base. Alright, you may need to write the numbers as an expression of the base. For instance, here we have 27 times 9 times 81. If I want to solve this using indices, I have to write all of them in the same base so that I can apply multiplication law, because this is multiplication. Now 27 is 3 raised to power 3. 27 is equivalent to 3 raised to power 3. 3 times 3 is 9. 9 times 3 is 27. Alright, now, like we just said, 9 is 3 squared. 3 raised to power 2. Because 3 times 3 is 9. And then 81 is 3 raised to power 4. 3 times 3, 9 times 3, 27 times 3, 81. Okay, so now I've written all this in base 3 as numbers in base 3. So you can now see that their bases are the same. So I can apply product law to this. I can now apply product law to this. So since I have 3, 3, 3, I just pick one. And then I add up the powers. 3 plus 2 plus 4. Which will give me 3 plus 2 is 5 plus 4. 3 raised to power 9. Okay, so this you can use a calculator to do to get the answer. 3 raised to power 9. Okay, so that's that for multiplication law. Then division law, the same is similar though. If you have two indices dividing each other and they have the same base, pick one of the base, subtract the power. So the difference here is that if it's division, you are going to be subtracting the power. So as long as the bases are the same, pick one base, subtract the power. So here I have 4 raised to power 5 divided by 4 raised to power 4. All I need to do here, since they are the same base, I pick one of the base, which is 4, and then I subtract the powers. This is 4 raised to power 1, which is 4. Okay, it's as simple as that. As simple as that. In this case now, like I said, sometimes you may need to write it in the same base. So I can write this as, I think 126 is 2 raised to power, is that not 7? 2 times 2 4 times 2 8 times 2 16 times 2 32 64 and 27. Yes, so 128 is 2 raised to power 7. 2 times 2 times 2, 7 times, divided by 16 is 2 raised to power 4. 2 times 2, 4 times 2, 8 times 2, 16. Now I've written this as indices in the same base. So I can take one of the bases and subtract the power, 7 minus 4, which is 2 raised to power 3. And this is 8. Alright, so very easy. Very easy. The same thing here. Just pick one of the base, subtract the powers. So y minus 2. Now, because this one is minus, remember to put this in a bracket. I mentioned this sometime. Remember to put this one in a bracket so that when you open it, we have y minus 2 minus y minus 1. So that this minus can affect everything in the bracket. In this case, you are just left with 3 raised to power y minus y is 0. That one will go minus 2 minus 1 minus 3. Okay, so that's that for division and multiplication. Just pick the base that is, if they have the same base, pick one of the base. If it's multiplication, add the powers. If it's division, subtract the powers. Now we have zero index law, a very simple law. Any number raised to power 0 is 1. Any base raised to power 0 is 1. Alright, so a raised to power 0 is 1, 10 raised to power 0 is 1, 60 raised to power 0 is 1. Alright, so just have that at the back of your mind. Any number raised to power 0 is 1. Then we have the negative index law. Negative index, that means we have a minus in our power, in our index. Now, a negative index automatically indicates a reciprocal. Reciprocal means 1 over. Alright, so the reciprocal of 2 is 1 over 2. That's the reciprocal. It's like turning it upside down, because you know that originally 2 is the same thing as 2 over 1. Normally, 2 is the same thing as 2 over 1. So the inverse, the reciprocal, if you turn it upside down, it will be 1 over 2. So whenever there is a negative power, it is 1 over. This minus in your index means 1 over. Then you write the base raised to the power under. I hope that's clear. Minus means 1 over. Then the base raised to the power under. So if, for instance, you have 2 raised to the power minus 3, the minus here in this power means 1 over, then 2 raised to the power 3. Just write the remaining ones under. And then 2 raised to the power 3 is 8. So this is the same thing as 1 over 8. Very clear, right? It's straightforward. Now we have 3 raised to the power minus 4. I told you minus itself means 1 over. Then 3 raised to the power 4. Write the base and the power under. Okay? And this will give you 1 over 81. I hope you're finding this easy. Alright? I don't think there's anybody that would not understand this, because it's quite simple. Alright? Now we have power law. Power law simply states that if a number is already raised to a power and then everything is raised to another power, that means a number has 2 indexes. Just like saying 5 raised to power 2 and then raised to power 3 again. If a number has 2 powers, it has an index and is raised to another index, you can just multiply the 2 powers. That's what power law states. So here I have a raised to power x and then everything raised to power y again. It's the same thing as just saying a raised to power x times y, which is a raised to power xy. That's just your index law, your power law, sorry. So here I have 2 raised to power 3 and then everything raised to power 2. We said you can write it as 2 raised to power, just multiply the powers, which is 2 raised to power 2 times 3 is 6, and then 2 raised to power 6 is 64. Okay, so as simple as that. As long as you have a power raised to another power, multiply the 2 powers. Okay, in this case, okay, for want of space, let me remove this. Let's say we have 25x plus 1. Alright, I can write 25 as 5 raised to power 2. Alright, because 25 is 5 squared. So I can write 25 as 5 raised to power 2 and then times this power x plus 1. Okay, the power does not go anywhere. Now in this case, we have an exponent raised to another exponent, so we just multiply the power. So this will give me 5, 2 times x is 2x, 2 times 1 plus 2. Alright, so this and this are the same thing. 25 raised to power x plus 1 and 5 raised to power 2x plus 2 are the same thing. Okay, and then finally we have fractional index law. Fractional index, when we have a fraction in our index, a fraction as our power. All right, now what if you have a fraction like this? What it simply means is that you take the denominator of the fraction, you take the denominator root as the denominator as a root of the base, and then raise everything to the power of the numerator. Okay, I will explain it with these numbers, but you take the the denominator is the number under, so y root of the base a, and then everything raised to the numerator x. So what do I mean? In this case, for instance, you have 64 raised to power 2 over 3. 3 is the denominator, the number under. So you take the cube root of 64, the denominator root of the base, and then everything will be raised to power 2. Okay? And then everything will be raised to power 2. Now if you go on to simplify this is cube root, and the cube root of 64 is 4. Cube root means number that will multiply itself 3 times to give you this. Square root is number that will multiply itself 2 times to give you the number. Alright, so cube root of 64 is 4, and then remember everything is raised to power 2. 4 raised to power 2 is 4 times 4, 16. So just remember that when you have a fraction in your index, take the denominator, the number under, root of the base, and then raise everything to the numerator. Now this one will give me, I have 27 raised to power 1 over 3. So I'm taking the cube root because the denominator is 3 of 27, then everything raised to power 1. Obviously anything raised to power 1 is still the same thing, so it won't change anything. So basically this is asking me to find the cube root of 27. I'm asked to find the cube root of 27. So take note that when you see any number raised to power 1 over 3, it means cube root. It means cube root. And the cube root of 27 is 3. Alright, 3 times 3 times 3 is 27. Now this one says 9 raised to power 1 over 2, which means the square root of 9, everything raised to power 1, which doesn't change anything. Power 1 doesn't change anything. Alright, now please take note that for 2, we don't write 2 here, we just use this sign. This sign means square root, and square root means a number that will multiply itself 2 times to give you this number. So do not come here and write 2. There's no need. Square root already implies that it's 2. Now the square root of 9 is still 3, because 3 times 3 is 9. So take note that when you see any number raised to power 1 over 3, it means cube root. Any number raised to 1 over 2 means square root. Any number raised to 1 over 4 means fourth root. 1 over 5 fifth root, just like that. Alright, so I'll quickly we'll do these examples. We'll simplify this, just to apply these laws more, and then we'll end this video. Alright, so give me a minute, let me clean the board. So let's solve this. Number 1, we have to simplify 16 over 81 raised to power minus 3 over 4. Now, remember, first thing, this is a negative index. So if you remember the negative index law, negative means 1 over. Then 16 over 81 raised to power 3 over 4. Alright, so first of all, this negative means 1 over, then everything here raised to this power. Okay, so that's the first thing. We have cleared this negative index. Then now, this is now fractional index law, 3 over 4. And we said fractional index means you take the denominator roots of your base. This is our base. 16 over 81 is our base. You take the denominator root of our base and then put everything to the power of the numerator. That means this will give me 1 over, our denominator is 4, so the fourth root of 16 over 81, the fourth root, the denominator root of our base, our denominator is 4, so the fourth root of 16 over 81, and then actually this is supposed to affect everything, because remember that the power is for everything, so this fourth root is actually supposed to cover everything. Okay, it's actually supposed to cover everything. Then everything here raised to power 3. Alright, I'll explain it again. Okay, I think it's not going to cover it. Let me take it again. We have this here. Let's keep our 1 over. It's not going to cover it. Now, fourth root of our base, fourth root of 16 over 81, fourth root of the base, then everything raised to the numerator. Alright, so the denominator of the root, denominator root of the base raised to the numerator. Now, this will give me 1 is still here. Now, what is the fourth root of 16? That means what number will multiply is there 4 times to give you 16? That number is 2. 2 times 2 is 4, times 2 8, times 2 16. So the fourth root of 16 is 2 all over. Fourth root of 81 is 3, because 3 will multiply itself 4 times to give you 81. So the fourth root of 16 is 2, fourth root of 81 is 3. Remember, everything here is still raised to power 3. Everything here is still raised to power 3. And then we'll go on, we have 1 over. Now, 2 raised to power. Now, remember, this power 3 is affecting everything inside this bracket. So it's not just for 2. It's both for 2 and for 3. Take note of that. 2 raised to power 3 means 2 times 2 times 2. 2 times 2 is 4 times 2, 8. All over. Then 3 raised to power 3 means 3 times 3, 9 times 3, 27. Okay, then finally, I told you that 1 over means inverse. That means the inverse of this, you're just going to turn this upside down. Alright, but let's solve it and you'll see. This 1 over this just means turn it upside down. But if you are solving it, remember 1 is the same thing as 1 over 1, then divided by 8 over 27. If you're solving fractions, if you're dividing fractions, you are supposed to change this division to times and then invert what is after the division sign. So whenever you're dividing fractions, change this to times and then turn the 1 after the fraction upside down. So 1 times 27 is 27. 1 times 8, 8. So this will give you 27 over 8 as your answer. 27 over 8. Okay? So that's for number 1. I hope it's clear. Just take it step by step. Remove the minus 1 over. Then express this, the denominator, fourth root of this, raised to the third root, raised to the third power. And once you can do that, you can solve the question. Then number 2 says we have this 4 raised to power minus half times 16 raised to power 3 over 4 all over 4 raised to power half. Now the first thing you do in this kind of situation is to put everything in the same base. Okay, if you have a number like this and you are seeing that this is indices because they all have powers, put them in the same base. So here, this is already in base 4, base 4. Let me just put this one in base 4. That's the simplest thing to do. And 16 is actually 4 squared. That's 4 times 4. So I can write this as This one will not change, but 16 is going to be 4 raised to power 2, then everything raised to power 3 over 4. Okay, so I've written 16 as 4 raised to power 2. This one is still there. All over 4 raised to power half. Okay. Now, if we continue here, now let's go on. Now we're going to open up this power. I mean, just multiply this by this. So we have, to multiply this, you can just cancel out 2 here 1, 2 here 2. So we're going to be left with 3 over 2 here. So that means I have 4 raised to power minus half times 4 raised to power 3 over 2 all over 4 raised to power half. Okay, now if I go on, remember multiplication law, these two have the same base, so I can pick one base, and since we are multiplying, I add their powers. So I have minus half plus 3 over 2. Okay, this one is still under here. Alright, so let me clean here so I can show you what I'm doing. Now we need to add these two. I hope you still remember addition of fraction. Although this one is pretty simple. LCM of 2 and 2 is 2. 2 into 2 is 1. 1 times minus 1, minus 1. 2 into 2, 1. 1 times 3, 3. So you have minus 1 plus 3, which is 2 over 2, which is 1. So that means up here we have 4 raised to the power 1 all over 4 raised to the power half. There are so many ways to resolve this, but I want to apply the laws of indices. If not, 4 raised to the power 1 is 1. 4 raised to the power half means square root of 4, which is 2. Then we are going to have 4 over 2, which will give you 2. But I want to apply the laws of indices. Now, this is 4 raised to the power 1 divided by 4 raised to the power half, meaning we can use division law. So since it's the same base, I pick one of the 4, and then I have 1, division is minus half. Okay, and definitely 1 minus half is half. Okay, you can prove it here, but I believe we are past that level. 1 minus half is half. So 4 raised to power half means square root of 4. Square root of 4, and that's 2. Okay, so this one is quite easy. 4 raised to power half is square root of 4, which is 2. And then the last one, 0.216 raised to power minus 2 over 3. The last one we are asked to simplify. Okay, now in this case, first thing you do, let's put this in, let's express this as a fraction. So this will give me 216 all over, this dot is 1, then these ones will be 0, 0, so 0, 0, 0. Okay, so this is 216 over 1000 as a fraction. Remember, it's still raised to power minus 2 over 3. Now, from here we'll go on. First thing you do, get rid of this minus, just like we did here. I remember negative index law, minus means 1 over. Then we'll still have 216 over 1000, now raised to power 2 over 3. So we've gotten rid of the minus by making it a reciprocal. Okay, now next step, we're going to take, it's almost like what we did here, the denominator root of the base, then everything raised to the power of the numerator. So our denominator here is 3, meaning we are going to take 1 over the cube root of 216 over 1000 then everything raised to the numerator 2, everything squared. Okay, so this will give me 1 over. Now the cube root of 216, which number will multiply itself 3 times to give you 216? That's 6 all over. Cube root of 1000 is 10. Alright, 10 will multiply itself 3 times to give you 1000. 10 times 10 is 100 times 10, 1000. Then everything is still squared. Okay, now we still go 1 over 6 squared. 6 times 6 is 36. 10 squared is 10 times 10, 100. Then obviously, like we did here, if you have 1 over 36 over 100, you just invert it. So this will give you 100 over 36. You can just invert it, right? If you want, you can do it like this, but I don't see the need to go this way again. Okay, so this is equivalent to 100 over 36. I've already shown it to you here. You can divide it, and then you change the division sign to multiplication and invert it. So you have 100 over 36, which if you reduce by 4, 4 divided 100 is 25. 4 divided 36 is 9. So this should be your answer, 25 over 9. Alright, so I'll give you 2 assignments and then we'll call it a day. So you have these 2 questions to try as an assignment. They are not difficult. 32 raised to the power minus 0.4. Just follow the rules. Okay, remember that you need to convert this to fraction. 0.4, that's 4 over 10. Convert to fraction. Remember this minus. Then here you have 0.027 raised to the power minus 1 over 3 times 0.093 over 2. Convert this to fraction, 27 over 1000. Convert this to fraction, 9 over 100. Then you reduce it to their lowest term. Manipulate with these powers. Remember this negative power and then fractional index. This fractional index. When you get your power, put them in the same base and then add up. Alright, so I hope this video was helpful. If you found it helpful, don't forget to like the video. It won't cost you anything, but it means a lot to me. Also, drop your comments drop your thoughts in the comment section so that I know what exactly, if you like the video or if there's anything you want me to improve. And then very importantly, share the video far and wide. Share it to as many people as you can share it to. Okay, and also don't forget to subscribe if you've not done that before. Hit that subscribe bell but hit that subscribe button, and also ring the notifications bell so that whenever we drop a new video, you'll be notified. All right, thank you so much. I'll see you in the next video.